serial communication. So first of all, so before entering into the serial communication, we have to know some basic fundamentals. So what are those? So we have the communication, right? So now
Data between two devices.
so communicating between two devices is nothing but you are actually exchanging the data, okay, or sharing the data. So communication
Yes.
is basically means, okay, thank you, Harsha. So basically communication means, so you are exchanging the data, okay, exchange, or you can say that, or sharing the data, okay, sharing the data between two devices, okay, two devices, we can say that, two entities, okay, we can say anything, okay, so or two bodies, okay. So this is the basic communication, okay. Communication basically means, so we are exchanging the data or sharing the data between the two devices or two entities, okay. So then come to the types of communication, okay. So types of communication,
No worries, sir.
okay, fine. So we already know the communication, so exchanging the or sharing the data between two devices, okay. Here we have the two types of communication basically, okay. So let's say here, so we have two types. So one is parallel communication, okay. Parallel communication, and we have serial communication. So just assume that, so now I want to communicate between two devices, so like so this is device 1 and this is device 2, okay. So this is the device 1 and here we have device 2. I would like to communicate between these two devices. So then we have the two types of protocols, okay. So when we are talking about the protocol, so then we have the wireless protocol and the wired protocol, okay. So but we will talking about the parallel and the serial communication. Some of the wireless will use parallel communication, okay. Most of the wireless communication will use the serial communication, okay. So the parallel communication is basically the wired communication will use the parallel communication, okay. So now let's see, so what is parallel and the serial. The parallel communication is means, so here the data will transmit simultaneously, so that is the meaning of the parallel, okay. Serial means what? So one by one basically. So here the data will be transmitted in the manner of bit by bit manner, so that's the name is called as in serial communication. So when you are transmitting bunch of data at the same time, so that is called as a parallel communication basically, okay. So just assume that here I have the 8-bit data, okay. So here I want to transmit 8-bit data from device 1 to device 2. So then we can use either parallel communication or serial communication. We have two types basically, okay. So now first of all I will use parallel communication. Let's see, so what are the features that will provide, okay. So now I will for transmit for simultaneous so for the simultaneous transmission, so we require so more number of lines. So here we have the 8-bit means, so we require 8 lines, okay. So here, so this is called parallel communication, okay. So just to take 8 lines, so these lines will interconnect the device 1 and the device 2. Okay. So we require an 8 data lines for transmitting 8-bit of data, okay. So let's say, so we have 0001. Okay, so we have like this. Okay, 0011 0011. Okay, so this is my data. So I want to transmit from device 1 to device 2, so using parallel communication. So then we require an 8 lines for the 8 bit of data. Okay, so here, so it will transmit 0 0. Okay, so like 1 1 0 and 0 1 1. Okay, so for 8 bit data, so we require 8 lines for transmission for simultaneously. Okay, so here it will, at the receiver, it will receive the 8 bit data at the same time. Okay, so this is called parallel communication. So you are transmitting all data in the same timing, so that is the meaning. Okay, so just assume that, so if I want to transmit 16 bit data, okay, so using parallel communication I want to transmit 16 bit data. So then how many lines required here? So for transmitting 8 bit data, so we required 8 lines. So why we required 8 lines? So because of you have to achieve the parallel communication, right? We have to transmit this data simultaneously. So that's why we required 8 bit data lines. So if I want to transmit 16 bit data, so then, so we have to use 16 lines for simultaneous transmission. So that's why we require a 16 bit data. So like that, if the number of bits goes on increasing, so let's say 32 bit. Okay, so then we require 32 bit data lines. So that will connected between your device 1 to device 2. So that is, so if you are increasing number of bits, so then the circuit complex will be high. Okay, because of the number of lines. So here this is the disadvantage. So now I want to transmit multiple data. Okay, so using a simple manner or simple communication. So then how you are going to choose, or how you are going to do that? So using serial communication. Okay, so using serial communication, so we can achieve the minimal number of wires. Okay, so that's why, so we are upgrading so this parallel communication into serial communication. Okay, as the name suggests that the serial communication will require only single line for communication. Okay, so in the single line, so it will transmit the data in the bit by bit manner. So that is the reason. Okay, that is the working in the parallel and the serial communication. So let's see so how it will work. So this is parallel communication. Okay, so now serial communication. So this is device 1 and device 2. So just it will require single line for communication. Okay, like this. Okay, device 1 and device 2. So how it will transmit the data? So now assume that, so I have 8 bit data. So similarly, the previous example. Okay, similar. So we have 8 bit data called 0011 0011, right? So how it will going to do send the data? So it will send the data in bit by bit manner. So first it will send 1. So after that it will send again 1 data. So then it will send 0 0 and 1 1 and 0 0. So like that. So it will send the data in the bit by bit manner. So but the difference is what? So it will not transmit the data simultaneous. Okay, so because of the serial communication, it will transmit bit by bit. So here in the parallel communication, it will transmit the data simultaneously. So here, so which one is the faster? So here, so we have the parallel communication is the faster, because in the single cycle, okay, so how you are going to send the data? So you internally, so they will record a clock, right, or system clock. So just say that, so in the t1 time cycle it will transmit this 8 bit data. Okay, so it will record only one time slot. So here, see here, it will record 8 time clocks, because in the each clock it will send single bit, right? So that's why we will record an 8 pulses for transmitting 8 bit data. So here we will record only single clock pulse, so for transmitting the 8 bit data. So here this is the faster as compared to your serial communication. Okay, so if you want to achieve the faster communication, so then you can go for the parallel communication, and the parallel communication is the short distance communication. Okay, so this is not an long distance communication. So this is mainly used for the short distance communication and the higher speed applications. Okay, so in the I2 serial communication, so this is the long range communication, so you can also use it in the slower application. So this is not much faster application, okay, as compared to your parallel. Okay, but because of the simplicity, so we'll go for the serial communication. Okay, and the most of the your wireless communication will use this serial communication only. Okay, so this is about serial communication and the parallel communication. Okay, this is the main difference. Okay, so now we'll talk about the serial communication. Okay, so now I will talk about serial communication. Again, in the serial communication you have different types. Serial communication, so you have two types again. So let's take so first one is based on the clock. Okay, we are talking about the clock, right? So in the previous explanation I have taken the name as a clock. So how we are going to transmit the data based on the system clock. Okay, so here, so based on the clock we are dividing two types. Okay, so if the communication will requires say a clock, so then we have one type of communication. If the communication do not requires any clock, so then we have another category. So like that. So if the communication will requires signal, so that signal is called as an synchronous communication. Okay, synchronous communication. And if the device do not require any clock signal for the communication, so then we can call it as an asynchronous communication. So this is the difference. So what is mean by synchronous and asynchronous? So the synchronous communication, serial communication. Okay, synchronous serial communication will use the separate clock signal for the synchronization or for transmission. So in the type of asynchronous communication, so this is the inbuilt. Okay, so this is the simply way of communication for exchanging the data between device 1 to device 2. So because it do not require any clock signal for the synchronization or for transmission. Okay, so that is the basic difference between the synchronous serial communication and the asynchronous serial communication. So then let's see the example of synchronous and the asynchronous. We already list out these three types of communication. Okay, here we have the UART and I2C and USB. Okay, so let's see which are those are asynchronous and synchronous. Okay, as the name suggests that, so here we have the UART. So another example is UART. So universal asynchronous receiver and transmitter. As the name suggests that asynchronous. So UART is nothing but the asynchronous communication. So here we have UART. Okay, UART. Okay. So then we have USB. So USB is also an asynchronous communications. Okay, so let's take about some synchronous examples. So we have I2C. So before we have SPI. Okay, so SPI serial communication or synchronous serial communication, and I2C synchronous serial communication. So what is the difference means? So these two types of protocols will use clock signal for synchronization, and these two protocols do not use or won't use any clock signal for the synchronization. And so other than we have important protocols also, we have CAN protocols. Okay, so CAN is the very important protocol nowadays. Okay, that should be used in the automobiles. Okay, in your cars. So this is a very booming technology. Okay, CAN. Okay, so this is the very important. So this is also one type of serial communication. So here we don't require any clock signal again. Okay, so this is also, you can take it as an asynchronous communication. So now here, so we'll discuss about UART. So later on we'll discuss about SP and I2C. Okay, so we won't discuss about USB and CAN. Okay, so then here we are only discussing about UART. So in this session, and then later on session, so we'll explain about, so I will explain about SP and the I2C communication. Okay. So now let us start with the UART. So we already know about the what is mean by communication and serial communication. What are the types of types of communication, and again we have types of serial communication again. So synchronous and asynchronous, and in the synchronous communication we have SP and I2C, and the asynchronous communication we have UART and USB. Okay. So then, so in the for parallel communication, we can also go for the RS-232, okay, or TTL logic. All these things are the example for the parallel communication. Okay, or we have the DB9 connector, right? So that are comes under parallel communication. So now UART communication. So UART means, so you already know that. So universal synchronous and asynchronous communication. Universal asynchronous receiver. So receiver and transmitter. Okay. Transmitter. Okay, so this is the stands for UART. Okay, so then what is mean by universal asynchronous receiver and the transmitter? Yeah. Okay, so if I want to communicate between device A to device B, okay, so in the very previous example, okay, so using UART communication now. Okay, so here we have the UART means, so this is the asynchronous communication. So then keep in the mind, so there is no clock is required for the communication. Okay, so then here, so how you are going to find out which one is the UART communication? Okay, so UART communication mainly uses two pins, okay, or two lines. Okay, so it will require two lines for the communication. So what are those? So first one is the transmitter line and the second one is the receiver line. So transmitter line and the second one is the receiver line. Okay, so it will require only two lines for communication. So how? So just assume that in the device 1, okay, so this is our system 1 and this is system 2. So if I want to transmit the some information from system 1 to system 2, so then we have to use these two lines. So the every microcontroller will have the inbuilt UART. So inbuilt UART means, so they will contain two lines. So basically used for communication. Okay, here the system 1 will have the two lines and system 2 also will have the two lines. So what are these two lines? So one is the transmitter line. Okay, so this is the transmitter line and this is the receiver line. So here also we have the transmitter line and receiver line. So then how the communication will happen? Okay, so if I want to transmit A, okay, so I want to transmit A from system 1 to system 2. So then now we are going to send. So just transmit. So you have to connect the transmitter pin to receiver pin on another device or the recipient device. Okay, so we have to make the connection like this if you want to achieve the communication. Okay, so connect transmitter to receiver and receiver to, okay, and receiver to transmitter pin on another device. So this is the connection of the UART between two systems. Okay, so this type of communication we can say that half duplex communication. Okay, so again the based on the communication we have again two types, okay, or three types. Okay, based on the operation, so transmitting operation. So we have half duplex. So this time is called as an half duplex, means so at the same time we can transmit and so after that we can receive the information, but at the same time you cannot do both. So that is the mean of duplex communication. Okay, so at a time, so you can send the data or you can receive the data. So that is the mean of duplex. So again we have three types. Okay, so we have three types or ways of communication. Okay, what are those? So we have already one of duplex communication. Okay, so this is the another way of communication, so that is called of duplex. So then what are other two? So of duplex communication means what? So here we'll transmit the data and you can also receive the data, but not at a time. So that is the meaning of duplex communication. So full duplex communication means what? So we can at the same time we can transmit the data or we can receive the data. So that is nothing but the full duplex communication. So we have another communication called, in that communication you can able to transmit we can able to transmit the data only. So that is nothing but the one-way communication. So that is called as an one-way communication. So that communication is called as what? Communication. Simply the name is called. The first one is simplex communication. Simplex communication means so you are able to transmit the data only. Okay, so that is called as an simplex communication or one-way communication. Of duplex communication is nothing but you can achieve the bidirectional communication but not at the same time. So full duplex communication means you can transmit or receive or you can achieve the bidirectional communication at the same time. So for example, of duplex communication and the full duplex communication. So full duplex communication you can take as an example for mobile phones. Okay, so in the mobile phones you can at the same time you can transmit the data or you can receive the data. So but in the walkie-talkies, so walkie-talkies is nothing but the half duplex communication. So the sender will transmit first, after receiving that information again receiver will send the information. So like that, so we have the communication called half duplex. So for example we have the walkie-talkies. Okay, simplex means so we can take only the transmitting the information. So okay, like antenna, so antenna will transmit the only signals, right? So like that we have the simplex and half duplex and the full duplex communication. Okay. So then so this is the your UART will use half duplex communication. Okay, so here, so how we are going to transmit the character A from device 1 to device 2? So just we have to put this data on the transmitter buffer register. So internally the UART will have the transmitter buffer register and the receiver buffer register. So first we have to put this data on the transmitter buffer register. So then the transmitter line will take that data and it will transmit through TX line, and that TX line is connected to the receiver. Again in the system 2 we have the receiver buffer register and transmitter buffer register. Okay, so it will receive the data and it will store that data into the buffer register. So we can read this buffer register, so we'll get your information. Okay, so if you want to send this if you want to send the information from system 2, so now I will send B. So then put this B data on the transmitter buffer register and this data will transmitted through TX line and it is connected to the receiver line and it will receive that data and it will store into the receiver buffer register. So like that. Okay, so if you want to read, so then read this buffer register. This is the working principle of the UART communication. Okay, so now so we have to remember another factor also. Okay, parameter also we have to know the other parameters. So what are those? So we have to know about the bit rate. Okay, bit rate and the baud rate. So what is bit rate and baud rate? The number of bits transmitted per second is the baud rate and bit rate, and the baud rate is nothing but number of symbols transmitted per second. Okay, so we can also say that the baud rate is also called as the number of bits transmitted per second, but specifically you can also say that it is a number of symbols or number of character transmitted per second. Okay, so that is the baud rate. Okay, so most of the microcontroller the recommended baud rate is 9600 baud rate. Okay, 9600 baud rate. So in that baud rate, so the information will transmitted. Okay, So that is nothing but you can take that 1 divided by 9600. So this is the rate for transmission. Okay. Rate of transmission. Okay. So like that, so we have to set the particular baud rate for achieving the particular communication speed. Okay. So then, so we have to, before you are working with the UART communication, we have to set the particular baud rate. So in which baud rate you are able to transmit the data, or you are going to communication between the device 1 to device 2, other device. Okay. So like that, the first thing we have to set the data for the serial communication. Okay. So after that, so the working internal working of your UART communication is, okay, so let's take, so it will so we are calling it frames. Okay, so internally, so they will transmit the information in the form of frames or packets. Okay, so the frame will be look like this. So the first, okay, your total data frame, or so data frame for the transmission. So the first pin will have the start bit. Okay, so we have the start bit, and then after that, so we have the data. Okay, so we have the data. After that, so we have the stop bit. Okay, so optional is the parity bit. Okay, so let's say take, so we have start bit, and you have 8 data bit. Okay, these are the data bits or user data. Okay, so then we have the optional parity bit and the stop bit. So this is the user data or data to be transmitted. Okay, so then this is the parity bit for error checking. Okay, parity bit. So then you have the stop bit. So like that, so the UART communication will happen. Okay, so first it will initiate, or it will give the hint to the receiver. So I am transmitting the data, so how it will give, so it will give by indicating the start bit. So if the start bit is received by the your receiver or the second system too, so then so it will, after that the start bit, so it will able to it is ready to receive the data, and it will store into the read buffer register or receiver buffer register. So then your master or system 1 will send the user data or the main data. So after that it will set the parity bit, and after that, so at the last it will set the stop bit. Okay, so here parity bit is used for the error 1 bit correction. So like that, so here we have the even parity and the odd parity. Okay, so even and the odd parity. So even and odd means, so even parity bit and odd parity bit. So if you are setting even parity bit means, so it will check the number of ones. So if the number of ones is even, so then, so that is called as an even parity. So and the odd parity is nothing but the number of ones will have the odd number. Okay, the number of ones is odd, so then it is nothing but the parity odd parity bit. Okay, so after that, so we'll give the stop bit for the end of the transmission. Okay, so this parity bit is the optional. So if you want, so you can add the parity bit. If you do not want, so then you can also ignore the parity bit. So just give the start indication, and after that, so you can send your actual data. So after sending the actual data, we can stop the communication. So like that, so internally your UART communication will work. Okay, so this is the UART communication. Okay, UART serial or synchronous serial communication. Okay, so now, so we'll go for the coding. Okay, so here we have to initialize the UART before using it. Okay, so here in the Arduino microcontroller we have the pins. So let's see the pins configuration of your Arduino board. So this is your Arduino board. So you can see here, so the first 0th pin and first pin will indicate a receiver and the transmitter line. So this is your UART pins. Okay, So 0 will act as an receiver pin and 1 pin will act as an transmitter pin. So this is your UART pins. So if you want to use this pin as an UART, so then you have to initialize the UART communications by providing with the specific baud rate. Okay. So these by default these pins will act as an GPIOs, right? So general purpose input output. So that are meant for only setting the pin as an input or output. So but now you are using this 0 and 1 pin as the different functionalities. So that's why you have to initialize this pin as an UART transmitter and the receiver. Okay. So we have the different inbuilt functions for doing that. Okay, in the Arduino programming, so just we have to use some inbuilt functions. Okay, so like here I will mention the inbuilt functions. So we have serial dot begin. So we have serial dot begin function and we have serial dot print function, and we have serial dot available function or serial dot read function, and we have serial dot available function. So much more we have another functions, but here we'll use these four main inbuilt functions in the program. Okay, so here so first we already seen the, okay, we already know the working of the UART communication. Okay, so if you want to achieve UART communication, first you have to set the baud rate. Okay, so on each baud rate you are going to operate, right, or you are going to transmit. So first step is we have to set the baud rate for communication. So then how you are going to set the baud rate? So using this function. So Arduino function will provide serial.begin. So in this function, so you can assign the baud rate for your communication. Okay. So then we have the serial.print. So if you want to transmit something, so then you can use serial.print. So if you want to read from the serial communication, so then you can use the serial.read. So then we have another function called serial data available. So it will check, it is used for checking the state. Okay, so whether your UART will have the data or not. So that purpose we will use the serial dot available. Okay, so these are the main basic four functions, so that will use it in the UART communication. Okay. So first of all, so I will take new program, okay, new file. So here I will write the code. So for initializing, okay, so just I will use serial, okay, serial, so dot begin. So why we require this line? So to initialize the pin number 0 and 1 as an transmitter and the receiver. So that purpose, so we'll use serial dot begin and with the baud rate. So you have to give the baud rate. So the recommended baud rate for the any microcontroller is 9600. So some of the microcontroller may get in a different baud rates. Okay, so but most of the microcontroller will set to the 9000, or recommended baud rate is 9600. Okay, so then so now you are initializing 0 pin as an, okay, so 0 as an receiver and 1 as so first pin as an transmitter. So that is the meaning. Okay, so then so if I want to print something or if I want to transmit something, so just use serial dot print. So okay, serial dot print. So I'll use here, so I welcome all. Okay, so this is the simple code. So now I will upload this code. Okay, so just I will upload. So you can also use the serial.print in the while loop also, so no problem. So you can see here, so what is the output? So hi, welcome all. Okay, so this is the message I have printed right here. So okay, here I need to print hi, welcome all. So that is the message I am getting on the output on serial monitor. So this is the serial monitor. So how we are going to open the serial monitor? So we have the right, on the right most corner we have the icon called serial monitor. Okay, you can see here. Otherwise you can also go for tools and click serial monitor. So then it will open the serial monitor and it will display the information whatever you are given in the serial.print. Okay, so then we can also use this function in the while loop also, so no problem. Okay, so but we'll get an so conflict information. Okay, so you can see here, so it will print continuously. Okay, instead of one. Okay, you can see here, so it will printing continuously. So now I'll remove this one. Okay, so first we have to know the different functions of serial print. Okay, so now just take one more print statement. Okay, so just I will take one more print. Hi, I will take that. Hi all, welcome to Abhiyantik Soft Lab. Okay. Abhiyantik Soft Lab. So we are expecting result as it has to print in the two new lines, right? So in the first line it will display I all. So in the second line it will display welcome to Abhiyantik Soft Lab. But so you can see here. So what it will use. You can see here I all welcome to Abhiyantik Soft Lab. So it will printing continuously with the previous statement, right? So now, so I want to print this to the second line. So I all in the first line and welcome to Abhiyantik Soft Lab in the second line. So we are going to do that. So either we can use escape sequences like a /n. Okay, this is for new line. Okay, done uploading. You can see here. So it will printing the first hi all in the first line and welcome to Abhiyantik Soft Lab in the second line. So now if you want to just use tab, so then you can go for the /t. So like that you can use the separate as escape sequences in the program. Now let us see. Yep, this will give the correct result. Okay, I all. So it will give the one tab of space and welcome to Abhiyantik Soft Lab. Okay. So now, so either, so we don't know about the escape sequences and all, so you can go for just go for print ln. So just I'll use print ln. Okay, so now let us see. So it will gives or it will print in the expected manner. Okay, so if you are missing in the print line, okay, if you are printing like this, so just assume that this is very important. Okay, so that is the print the difference between the serial.print and the println. So println means what? So first it will print this statement, after that it will jump to the new line. Okay, so if I printing like this, if I am using like this, okay, I will print this statement and here I will use println. So then let's see what will happen. Here we are come up with the same issues because you can see here. So here we are just using the print. Okay, there is no new line in this statement. So here we are printing welcome to Abhiyantik Soft Lab. So after that it will give the new line. Okay, so you can see here now I will print something, so that will come or it will display in the new line then. Okay, so there's print. So internship programming. Okay. So now you can okay, you can upload. So you can see here, so it is printing in the new line. So like that. So if you want to print so in the each statement in the new line, so then go for ln. Okay, so ln. Okay, you can see here I all welcome to Abhiyantik Soft Lab internship program. Okay, so otherwise you can also print like this. Okay, Okay, so you can also put this statements in while loop. Okay, no problem. So let's upload the code. You're uploading, but you are it will printing continuously. Okay, so you're not able to see the result in the respected manner. Okay, so now just so if you want to print in the slow motion, so then go for delay. Okay, or delay version. Okay, so just I will go for 0.5 second. So every 0.5 second it will print this all information. So I all welcome to internship programming by Bantry Softline. Okay, so like that, so we can also display each line. Okay, so here at the same time it will print all these three lines, right? So you can also give the delay for each line. Okay, so just give delay. So here I will take 500, and after that I will give delay as 300, and here I will take 200 and upload the code. You can see here first it will display hi all, welcome to Aviantrix. Okay, welcome to internship programming by Aviantrix. Okay, so you can also increase the delay. Okay, just I will take here 1 second. Here I will take a heat 700 and I will take a 500. Hi all, welcome to internship programming and by Abhyantar Software. Okay, like that. So you can use in the interactive manner. Okay, you can use the this serial print. Okay, or you can use serial communication, UART communication. Okay, so here actually, so where this information will getting. So first we are uploading the data. The microcontroller will sending this data to your laptop. Okay. So if I disconnect hardware, so then there is no connection between your controller and the laptop, so then it will won't display anything. Okay, so let's see here first of all. So your Arduino board is connected, so that's why you are getting the data. So now I will disconnect this Arduino. Okay, so just I will remove, so it will stop printing the information. You can see here, so it will stop printing. Okay, otherwise I will clear the outputs. So you can see here it's not printing. Okay, so again once again, so we can open the sketch or our serial monitor. It's not displaying anything, it's empty. So now I will connect the Arduino board. Okay, so it is turned on. So then turn on. Okay, open the serial monitor, so then we'll find out the result. Okay, so now I will clear the output, so it will printing. Okay, it's keep on printing the information. Okay, again I will clear the display. Okay, see here. So that means, so the microcontroller will sending this information, so and your laptop will receiving that information and it will display on the UART. Okay, so that is nothing but the communication will happen between the your board to your laptop. Okay, so this is the simple serial communication between the any devices. Okay, or your Arduino devices. So now, so just I will show you the another function in the serial or UART communication. So the you can see here, so it will printing something. Okay, so then I'll clear and again I will open. So it will printing Hi all, welcome to the entrance in programming and by Abhyantar Lab. So now I'm printing. Okay, I'm typing something. Okay, so let's see. Once again, I will upload. So hi or okay, I will printing. So here I'm entering something, but it's not displaying. Right? You can see here, it's not displaying. So now my requirement is, so I want to display so this information what I am typing here, so that has to display in your serial monitor here. Okay, so like if I enter hi, so it has to display hi. So if I am entering hello, so that has to display hello. So like that. So then we have the another function, so you can remember here, so we have listed some functions. Okay, serial dot begin, so we already done with these two functions. Okay, serial dot begin and serial dot print. So now, so if you want to read the information from the serial monitor or UART, so then you can go for the serial dot read. So now, so just I'll remove this line. Okay. Okay, here I will print like that. So, okay, so the initial message. So I'll give initial message. What? So type any character, and hit enter. Okay, and send or hit enter something. Okay, type any character and hit enter. So this is the initial message for user. Okay, so I'll take 2 seconds. I will wait for 2 seconds. Okay, then so we have the function, right? So okay, see here, so we have the function called serial read and serial dot available. So first I will check the data, so whether the data is available or not. So here we are tapping the data, right? So this is nothing but the data. So serial data available, so that is nothing but if you are if you are is start receiving the data, so then only so I want to read the information, so that is the meaning. So that purpose I'll use some condition here. Okay, so just for here, if serial dot available, okay, so greater than 0 0 is nothing but what, so the receiver will or what receiver pin will receive the data. Okay, or so if you are entering the data on the serial monitor, that is the meaning of you are checking the condition, so whether data is available or not. So serial dot available greater than 0. So then, so just I will read that information and I will print that information. So we are going to do that. So just I'm reading. Okay, just I'm reading the data and printing the data. So this is printing the data. So what you are printing? So whatever I am reading from the serial receiver pin. Okay, so that's why we have the read function. So, okay, so this is the read function and this is the print function. So just upload the code. So we have expected. Okay, so here we have to use semicolon. Then uploading. Okay, open serial monitor. So it will print the initial message or type any character and hit enter. So now I will type hi. So we are getting something 1. So we are getting something. Okay, so we are not getting what I am entered here, right? So we are getting something else. So what is this means? So we are getting ASCII value. Okay, so let's say, so here I am entering small a. So what is the ASCII value for small a? Character. Okay, so now I will print, okay, string. Okay, so if I want to print or if I want to read string, and I will display the string, so then just use, instead of serial read, just use the string. So string and upload the code. So we'll get the entered information as it is. Okay, so here, so now I will type hi, so we'll get hi. Okay, so then hello, so then you will get hello, right? So name, cry, cry. Okay, fly. So like that. So what you are entering in the serial monitor will getting same thing, right? So that is nothing but the reading string and reading character. Character means, so it will display one by one. So that is nothing but the character. So string is nothing but group of characters. So what we are entering in the this search bar, so that will display as it is. Okay, so now I'll like this. Okay, so it will display as it is, right? So if I'm typing number, so it will display number. Okay, then I'll also type special character. Okay, right? So it will display so as it is. So now, so see the difference. So in the character, so it will display single character at the same time. So see here and upload the code. So now you can see here. So then okay, good. So you can see the first Z is received and it will display like that. Okay, so first it will display Z O O D, right? So like that. So now I'll take I. So it will type hi. Okay, then hello. Okay, so I have so like this. Okay, so this is character. Okay, you can see here this is a character and that is the string. So this is a different way of reading the information from the serial monitor. So this is all about the UART communication and the programming in the Arduino IDE. Okay, or Arduino. This is the Arduino programming or UART Arduino programming. Okay, so this is simple, right? So just if you want to print something, so then you can use the serial.print. If you want to read the information from the UART, so then you can go further, just use serial.read. Okay, right? So this is the all about UART communication. Okay.